I am Tse Yuet Tung from the Kong Metropolitan University. The issue of human exposure to microplastic has drawn the public concern due to its potential health risks. Researchers have found a certain level of microplastic contamination in the bottled water. However, the majority of the findings only provides the total abundance of microplastic and no size distribution information, especially for microplastic size between 1 to 50 micrometers, due to the restrictions of the conventional microplastic analysis method by visual inspection. Only a few studies using micro-Raman spectroscopy to achieve the analysis of smaller microplastic. But these techniques are extremely time-consuming and only determine a small portion of the microplastic. In this research, we demonstrate the use of flow cytometry to rapidly quantify microplastic with size less than 50 micrometers. In combination with the use of microscopic technique, we can evaluate the abundance of the whole spectrum of microplastic. Regarding to the result, the abundance of microplastic with size larger than 50 micrometers were similar to other studies, and fragments microplastic was the dominant shape found in the sample. Our results showed that different brands and types of bottled water were all contaminated with microplastic. What's more, the abundance of microplastic smaller than 50 micrometers in size were dramatically higher than that of the large microplastic by more than 30 times. The results reflect that the contamination of smaller microplastics pose a more serious threat to humans. Apart from that, we analyzed the size reference bin to establish a standard curve to estimate the size of the detected microplastic. According to the size distribution of 9 brands of the bottled water sample, microplastics smaller than 10 micrometers contribute most of the abundance, and the highest abundance of the microplastic was found in size around 1 to 2 micrometers. Our results can provide the distribution of microplastic with particular size instead of a size range, which can aid to more accurately assessing the potential risk of microplastic by selecting the proper size of microplastic in toxicity tests. All in all, we used the novel method, flow cytometry, complemented with traditional microscopic counting for evaluating the whole spectrum of microplastic contamination profile in bottled water. And our finding manifests that the abundance of microplastics smaller than 10 micrometers in size posing a substantial risk to human health, and more attention and effort should be invested in lowering the microplastic contamination and investigating the potential impact of small microplastic. Thank you.